Okay, welcome listeners to The Deep Dive. Today we're digging into a really fascinating report from the Associated Press. Uh, Honestly, it sounds a bit like science fiction at first glance, but nope, this actually happened. Our mission, as always, is to go beyond just the headline. We want to unpack this specific event and pull out what it really tells us about, well, where AI and robotics are heading, what this means for the cutting edge. So picture this. It's a Saturday night in Beijing, busy place. But on the field, you don't have people. You've got these humanoid robots, 4 teams of them.
Gleaming agile ones, apparently.
Right, kicking, passing, scoring goals, and the key thing, all on their own.
Mm-hmm.
This wasn't some movie set piece or, a super controlled lab test.
No.
It was China's first fully autonomous 3-on-3 AI robot soccer match.
Yeah.
So when you hear that, 4 teams of humanoid robots playing 3-on-3 soccer, what's the first thing that jumps out to you? What's significant?
Well, it's a combination, really. You've got fully autonomous, humanoid, and that dynamic 3-on-3 setup. I mean, robot soccer isn't brand new, but this feels different.
How so?
It's not just a machine programmed to nudge a ball, right? We're talking about 4 distinct teams, robots that look and move, sort of, like people.
Bipedal.
Yeah, bipedal.
Yeah.
Competing, interacting, in a pretty complex, unpredictable game environment that feels like a step beyond the usual controlled demonstrations we sometimes see. It's pushing into real-time adaptive intelligence.
Okay, let's focus on that fully autonomous part, because I think that's crucial.
It is.
For our listeners, many of whom follow AI closely, what does that really mean in a fast-paced game like soccer? It's more than just no remote control, isn't it?
Oh, absolutely. Yeah, definitely not just no joystick. Fully autonomous here means basically once the game started, the humans stepped back completely.
Completely.
That's the idea. Their AI was doing everything, seeing the ball, figuring out who's a teammate, who's an opponent, deciding the strategy, like should I pass or shoot, and then actually doing it, making the physical moves.
Right.
And all this without humans feeding them instructions or, running pre-baked scripts for every single possibility.
So it implies some pretty advanced stuff running under the hood, like vision, decision-making.
Exactly. Real-time computer vision, complex pathfinding so they don't bump into each other constantly, decision-making algorithms that have to adapt during the game. It's a massive leap from, say, an industrial robot just welding the same spot over and over.
Right. So just to kind of sum that bit up for you listening, we've got these robots, shaped like humans, playing a team sport, making their own calls, all driven by AI. It's pretty remarkable independence.
It really is.
Okay, so that brings us to the next logical point, the challenges. Building an AI system that can actually do this in a messy, dynamic game like soccer.
What are the big hurdles, especially because they're humanoid?
Yeah, this gets into something called embodied AI. It's a huge challenge.
Embodied AI, meaning the intelligence is tied to the physical body. Precisely. For these humanoid robots, it's not enough to just think smart. The AI has to translate those thoughts into stable, agile, physical actions instantly. Think about how a human player does it, right? You see the ball coming, you shift your weight, maybe take a step, adjust your balance, kick. It's almost subconscious.
But incredibly complex physically.
Incredibly. Now imagine programming a robot to do that. Maintaining balance while running, turning sharply, kicking, maybe on a surface that isn't perfectly flat. It's unbelievably hard for a 2-legged robot.
Falls must be a content risk.
Oh, definitely. So the AI isn't just strategizing the game, it's constantly managing the robot's own body dynamics, momentum, friction, balance, predicting, and maybe even recovering from stumbles, all while processing the game state and deciding what to do next. It's teaching AI to have physical intelligence, resilience.
That's a great way to put it. Physical intelligence. It's so different from an AI playing like a board game.
Totally different. Chess or Go have fixed rules, a predictable environment.
Right. Digital.
Yeah. This is physics. This is the real messy world with unpredictable opponents moving around.
And the humanoid shape itself makes it harder, doesn't it? Compared to, say, a robot on wheels.
Absolutely. Wheels are stable. Legs. Legs are inherently unstable. So the AI has to constantly solve these really complex problems of balance and movement, almost like learning to walk a tightrope while playing soccer.
Wow.
It really pushes things like reinforcement learning, where the AI learns by doing, by trial and error, not just in clean simulations, but out there in the physical chaos.
So it's a shift from AI that just knows things to AI that can actually do things physically.
Exactly. Doing things with a high degree of physical skill and adaptability on its own.
Okay, so let's connect this back for everyone listening. This robot soccer match in Beijing. It's cool, maybe a bit strange, but Why should you care?
Yeah.
What's the takeaway beyond the novelty factor?
Well, this match, it's more than just a game. Think of it as a very public, very demanding test bed for really advanced AI. The skills these robots needed, seeing and understanding the environment in real time, coordinating with teammates.
Making quick decisions under pressure.
Right, and then actually carrying out complex physical actions in that dynamic space. Those abilities are hugely transferable.
Transferable where? What are we talking about?
Well, it's not just about making better robot soccer players, obviously. It's about pushing AI to handle the messiness and unpredictability of the real world.
Okay, so give us some examples. You listening might not be worried about a robot taking your spot on the Sunday League team.
Probably not yet.
But where might this underlying tech show up?
Think about logistics. Imagine automated warehouses, but much more chaotic than today's. Robots needing to navigate around dropped boxes, unpredictable human workers, maybe other robots. That requires similar perception and coordination.
Okay, that makes sense. What else?
Or search and rescue. Picture a disaster zone.
Difficult terrain, unstable structures.
Exactly. A humanoid robot might be better suited than a wheeled one to climb over rubble, open a door, check for survivors, identify hazards, all autonomously, because direct control might be impossible.
So it's about AI learning to function in places that aren't neat and orderly, like a factory floor.
Precisely. Moving from structured, controlled environments into unstructured, dynamic ones. That's a major frontier for both AI and robotics.
So this event, this soccer match, it really flags up a significant shift then.
I think so, yeah. It shows AI systems moving beyond just processing data or playing digital games. It shows them becoming capable of embodied intelligence, acting physically, robustly, autonomously in the real world. It's a pretty compelling glimpse of where things might be headed.
So from this one event in Beijing, a soccer game played by AI-powered humanoid robots, we get this really fascinating insight into just how fast things are moving in AI and robotics. It's a solid reminder that, the future isn't just something we talk about. It's actively being built, being tested, one autonomous goal at a time, I guess.
Yeah, absolutely. And maybe this leaves you with a question to think about. As AI and robotics get better and better at these kinds of complex, physical, real-world tasks, the tasks that used to require human adaptability and dexterity, how might that start to reshape industries? And maybe even reshape human roles within them, especially in jobs that need that quick thinking, physical skill, and real-time decision-making in unpredictable settings. Something to maybe mull over.